Alright, so this is example 10 from the MCA review, graphing quadratic equations. I'm doing this one a little bit differently. I don't have everything pre-planned just because I want to work through every single part together and then show you on the graph what exactly needs to be done. So calculate and write the equation for the axis of symmetry. So that's this one right here. So I'm going to grab a pen. It's a little bit more difficult when you go through and write it because got to use a mouse instead, but that's okay. So we got to think about this. So calculate and write. So to calculate it, remember we have x is equal to the opposite of b divided by 2a. Now if I look over here, remember the number that goes with the x squared, this is a. The number that goes then with the linear term, meaning the one that's just the x, that's b. And the number that's all lonely by itself, that's c, because that's the constant. So I just take the values that we have there, substitute them in. So the opposite of b, well, I'm given a negative 6. So the opposite of b is 6. A is 1, so therefore 2 times 1 is 2. So then I have that this is 3. So now I've calculated it, but now I have to write the equation for it. So remember, the equation is always starts out x equals 3. Now I should be able to draw a line at x equals 3. So I'm going to, let's see if I can actually get this to draw one for me. So I'm going to pull out a dashed line. So we'll change the endings here. That's what we look like. Line style, I want it dashed because it's not part of the graph. Then we'll put arrows at the end. Okay, so let's see, 3. So we've got x is 1, 2, 3, so it's right along this axis. And we'll just have to extend it so it goes all the way through. And shift it over a little bit. Oh, maybe. That looks good then. Alright, so there's my axis of symmetry. Now I got to go through and figure out the vertex point. Now remember, the vertex point is the turning point of the parabola. So in this case, as I look at A is positive. So is this going to open up or down? Alright, so good. It's going to open up, and the reason it opens up is because it's positive. If that value in front of the x squared was negative, this entire parabola would open downward. Okay? Alright, so now we already know what the x part is for the vertex. I'm going to choose a different color here. Let's go with green. So we already know that for the vertex, 3 is the x component. We know this because the vertex is going to lie on the axis of symmetry somewhere here. It's always going to do that. Okay, remember the axis of symmetry is like the folding point or folding line. Okay, for a parabola, one side mirrors the other because it's symmetric. So if I have that the x is 3, I'm literally just going to substitute 3 in here. So I've got f, that's a really bad parenthesis, but that's okay. F of 3 is equal to 3 squared minus 6 times 3 plus 8. Now, order of operations says that I have to deal with exponents. I have parentheses in here, but there's nothing that can be done inside them. So now I've got to deal with exponents, so I'm going to get 9. And I'm going to do every step out so I don't lose anyone. So everything else comes along for the ride for now. Okay, I'm going to have to extend the page. Back to my handy-dandy green pen. So then I get 9 minus 18 plus 8. I'm getting better at this using the pen. Alright, so 9 and 8, that's 17. So 17 minus 18, that's going to give me a negative 1. So that means when the value of the function, if I have it that x is 3, y is at negative 1. So then I come back up here. That's my vertex point. Alright, so now let's go over to our graph. There's going to be a lot of scrolling back and forth, okay? So now let's go back to my graph. I need to be at 3, which makes sense, and negative 1. I'm going to see if I can just darken a circle there. Okay, so there's my vertex. I'm going to put a little V here so we know that that's my vertex. Alright, So going back to the next question. So we've already done this one. We've already done this one. So state the y-intercept. Now remember, the y-intercept is when x is 0. So if x is 0 here, x is 0 here, x is 0 here, all of this goes bye-byes. So now I know that my y-intercept, So now I know that my y-intercept, okay, is the point we start at 0, because that's my x value, and I will cross the y-axis at 8. So I'm going to go up here, so 0, 1, 2, 3, 4, 5, 6, 7, 8. Now, remember that this is a mirror image. So I notice that I'm 1, 2, 3 away here. I might as well go ahead and get 1, 2, 3 away on the other side. I know that's a point because here's my axis of symmetry. If the distance from here to here is the same as the distance from here to that side. All right, so now we've got that. State the reflection point of 1, 3. So in other words, if 1, 3 is a solution to this, which it is, so I'm coming out here at 1, 1, 2, 3. If 1, 3 is a solution point, again, let's mirror. I'm going to reflect onto the other side, so I'm 2 away. I need to be 2 away here. All right, so what's that location? Well, before I was here at 1, 2, 3, 4, 5. And then how far up am I on the y-axis? Well, that's going to be 3. So don't get caught up with reflection point. It's literally just whatever's on the other side. So for the reflection point here of 1, 3, it's just 5, 3. State the x-intercept. So I need to figure out where it crosses the x-axis. I'm thinking as I look at this, right, I've got to come through, I've got to come up. I could get some ideas as to where it's going to cross. Like, more likely than not, it's probably going to cross right around here. But I've got to be able to do this for real. I can't just say, oh yeah, it looks like it's going to be there. So we've got to then go through, let's use a different pen just because we're getting a little tight with space here. So I'm going to have to factor this. All right, so f of x, again, is equal to x squared minus 6x plus 8. I'm sorry for the clicking of the mouse. I haven't figured out quite how to not hear that annoying sound in the background. All right, so what I need to do in order to find out where it crosses the x-axis, which is also known as the zeros, my x squared minus 6x plus 8 has to equal 0. Remember, we call them zeros of the function, also the x-intercepts. It's where it is 0. Well, let's see if I can factor this. This would be a lot easier if I could factor. Do I have any common values I can take out of x squared, negative 6x, and 8? Right, there's nothing. Okay, there's no number in front of here. I can take a 1 out, but that's not going to help me any. They don't all have x's, so I can't do anything with that. So now I look here. Remember, this is just like the review of, let's see, which number was it? Number 8, where we're just factoring. So the first terms in each are x. What does this sign tell me? And then based on that, what does this sign tell me? Well, remember, this sign tells me that the signs are the same down here. This one tells me that then the signs are both negative. All right, so now I got to figure out factors of 8 that add to give me 6. So 1 and 8, no, that doesn't add to give me 6. 2 and 4, that one adds to give me 6, so I'll put a 2 here and a 4 here. Now I'm almost done. I just got to figure out what x actually equals. Okay, so what values of x would make this whole thing 0? If I put a 2 in here, 2 minus 2 is 0. 0 times anything is 0. So 2 works. Then I look here. What value should I put in here to make it so this is 0? And remember, it's basically like looking at it and saying, hey, you know what? It's the opposite sign, and that number is the opposite sign, and that number. So if I put a 4 in here, 4 minus 4 is 0. Who cares what this is? Because if this is 0, when I multiply, I'm going to get 0. Alright, so now I need these as points. So these are the points for the x-intercept. So I know x is 2, and I'll just temporarily start the other one. And I know that x could be 4. Well, if I'm crossing the x-axis, which is then my x-intercept, what's the value of y going to be? Exactly. Okay, it's going to be 0. So now I have the points for my x-intercepts. So let me just put a little marking here that that's what this is. This is your x-intercept. Come on up here. 2, 0. No, 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 no. And 4, 0. No, 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 no. There are 2 x-intercepts. And we can now place those on. Oh, and we actually already finished that. Graph and the function and label are all parts. All right, so let's choose a different color to go ahead and sketch our graph here. So we haven't used blue. Now I'm going to try my best, but again, remember, I'm using the mouse. It's not too bad. Okay, and then I've got a nice little, oops, it's not aligned. Take a little curve, come through this way, cross through here, and there's my Poavoa. Now I've got to label parts. A little difficult for me to go through and label right here, but you would label this point right here. Where are we? We are at 1, 2, 3, 4, 5, 6, 8. We know that this point is 4, 0. We already said what the vertex point was, and that's why that's there. And then we just go ahead and label those. And then remember, I'd want to say that the axis of symmetry, and remember, this has to be an equation. Wow, it's really bad handwriting, I apologize. So this is x equaling 3. Notice also I'm labeling my axes. Got to make sure you label those. Alright, so hopefully this was a little helpful with trying to deal with something like a number 10. So all parts are labeled. We went through this kind of an equation will actually be given to you on the MCA. Happy, happy, joy, joy. You still have to be able to pull apart the parts. You still have to be able to figure out all of this stuff. Okay, now you were pretty good at this in class, so hopefully that'll maintain. All right, thanks.